This lesson is for Advanced Algebra, Lesson 8.8 on solving equations with radicals. So this is our last lesson of Chapter 8. Most of the time students will be allowed to use a baby calculator only, but there will be some instances where a graphing calculator will be allowed. We need to quickly review what happens when you're solving and there's exponents and roots involved. First of all, if there's an exponent involved, I'm sure most students are pretty comfortable using a root to cancel it. The cube root will cancel out a cubed power, just like a square root will cancel out a power of 2. So the cube and the root here will cancel each other out, leaving us cube root of x as our answer. Keep in mind that we've also learned this year that to get rid of a power, you could also use a reciprocal power. So we could also raise to the 1/3 power on both sides, because 3 times a third, or a number times its reciprocal, will turn into y to the first, or just y to the 1 power. So we could say that the answer is x to the 1/3 power or the cube root of x. Those are both equivalent to each other, and it's perfectly fine for students to solve in either fashion. Keep in mind that our focus here is going to be on the radical one. So it's not wrong to use a reciprocal power, but know that the radical is going to be our focus. One thing to keep in mind when you're solving is that it's going to be best for you to move things or stuff that's the farthest away from the x or your variable first. Be careful here on this first one. It's cube root of x plus 2 equals 9. I want to distinguish that from cube root of x plus 2 under the radical equals 9. Notice here the 2 is under the bar, and over here on our problem that we're going to do, it's not. That does make a difference in terms of what you're going to do first. So this radical bar will group the x and this 2 together, meaning that we're not going to subtract 2 on both sides first on this one. We will on the one that we're going to do though. Here we would take away the 2. That leaves us cube root of x equals 7. And now to get rid of a cube root, we would not raise to the 1/3 power, we'd raise to the 3. A power of 3 will undo a root of 3. So if we do that, now the root and the power cancel, and we get 7 to the 3rd power is not 21, it's 7 times 7 times 7, which is 343. Keep in mind here that you can check your answer by just typing it into your graphing calculator. Cube root of 343 plus 2 should equal 9. So that's one type of problem you may encounter. Another type is when you have a number in front of the root. Again, I want to distinguish this one as not being a 5th root. Notice that that 5 is not little, it's big. It's the same size as the 3 that's under the radical. Here the 5 is little, meaning it's a 5th root problem. So that's not what we're doing here. We're doing 5 times the square root of 3y plus 1. So the thing that's the furthest away on this one is the 5. The 5 is currently being multiplied, so to undo it we're going to divide. Remember that what you do on one side you have to do to the other. The cube or the square root symbol is still there, and then on this side we need to go ahead and divide. Make sure you do top divided by bottom, and so on that you're going to get 16. Next, we can't move the 1 yet because the 1 is stuck underneath this radical bar. Remember that the radical bar behaves like a grouping symbol, so it's putting the 3y and the 1 together, and those cannot be separated until this bar goes away. So let's make the bar go away. Remember, this is a square root, so to undo a square root we would raise both sides to the power of 2. The 2 and the root now are going to cancel, leaving me the 3y plus 1 no longer under the bar. And 16 squared, you'd have to, if it was a baby calculator, you'd have to say 16 times 16. You get 256 there. From here on out, it's just regular Algebra 1 going on. Hopefully students know to subtract 1 from both sides and then divide by 3. So those steps don't even need to be shown at this point because I'm assuming students are good at those steps by now. So divide by 3 there, 255 divided by 3, you get 85. Again, you'd want to go ahead and check your answer by typing it in on a graphing calculator. Another type of problem students are going to run into is when there's multiple things going on and when there's fractions under the radical. I want students to see an example of that. Notice here that we're solving for L. L is under the bracket, so one of the things we're going to have to do is get rid of that radical bracket eventually. But the thing that's further away is the 2 and the pi. Technically, we could divide by 2 here and then divide by pi, but since they're both being multiplied at the same time, it's faster just to deal with them both at once. So we're just going to divide by 2 pi on both sides. Be careful here, the 2 divided by the 2 is going to make a 1. That doesn't mean that our answer here is just pi. The pi, remember, is being divided, so it's on the bottom. So when the 2's cancel, they do leave a 1 behind, and the pi is still on the bottom of the fraction. Then we're going to get rid of either the 980 or the square root. The 980 can't move because if we start to move him, he's going to hit this radical bar. So the bar has to go away before we can move the 980. Since it's a square root, I'm going to square both sides. Keep in mind that we need to square the top and the bottom of that fraction. So that's why I added in extra parentheses there to remind myself to do it to both. 1 squared is 1, and pi squared would end up being a decimal. And I don't want to round here, so let's just leave it as pi squared for now. If they want me to approximate it, then I would go ahead and type that in. On the other side now, the fraction has been set free from the radical bar. So now I'm going to get rid of the division of 980 by multiplying by 980 on both sides. Another issue here that can trip kids up. It's confusing for kids to figure out if it's 980 times the top or 980 times the bottom or both. If you're not sure, remember to turn 980 into a fraction. 980 should be over a 1. That means the 980 is just going to go on the top, and on the bottom we will still have pi squared. And I'm fine with students leaving it like that as your final answer because that answer has not been rounded. If they do want you to round to a particular decimal, then you would go ahead and type it in and you'd round accordingly. The final topic for today is extraneous solutions. Sometimes when you're solving and there's a radical involved, particularly when a negative shows up, sometimes the answer does not check. So when that happens, all you're going to do is label your answer as extraneous at the end. So let me show you what that looks like. We're still going to solve just like normal. Be careful here, this 3 is not being subtracted. It's actually being added. What's being subtracted is the 4th root of y. So to get rid of the 3, we should subtract 3 from both sides. Common mistake there is for kids to add 3 to both sides. But if you look at it, 3 plus another 3 is not going to make 0. And we want a 0 because we want the 3 to go away. 3 minus 3 is 0, that's good. The negative drops, the 4th root of y is still there. Over here we're going to get a 7. Now to get rid of this negative, we would multiply everything through by a negative number, or a negative 1. You could also divide both sides by a negative 1. Either way it'll still work. If we do that, the 4th root becomes positive and the 7 becomes negative. At this point, based on what we talked about yesterday in lesson 8.7, it should occur to students that something is terribly wrong here. Whenever you do a 4th root of something, we know that the result is always going to be positive. So the fact that they're trying to get us to make a negative out of that doesn't make sense. So right about here is where I'm going to say, you know what, I'm guessing this is one of those problems where there's going to be an extraneous solution. So we'll just make a mental note there and then we'll keep going. We're still trying to solve for y. This radical bar is in our way. It's a 4th root, so to undo it, I'm going to raise to the 4. Keep in mind that that negative and that 7 go together, so the parentheses need to be there. If I do negative 7 to the 4, I'm going to get a positive number. That's the problem with this particular solution that we're doing. If I try to plug in now 2401 back into the original for my check, 3 minus the 4th root of 2401, let's see if that equals 10. I'm guessing it probably isn't. So 3 minus, I would want to do the 4th root here. I know the 4th root of 2401 is going to be a 7. And 3 minus 7 is definitely not equal to 10. So because of that, I did everything I was supposed to do. I arrived at an answer, but it's an answer that doesn't work. So then I'm going to say this is an extraneous solution, meaning something's wrong with the original problem. The original setup here was incorrect. This doesn't work. You can't do a 4th root and get a negative 7 like what we got. So that's not our problem, that's not our fault, but we're just going to label it that way to draw attention to the fact that we did what we were supposed to do, the problem itself was incorrect. That's it for the notes for this video. I want to explain one more item, however. In the homework for this lesson, there is talk about the distance formula in a coordinate plane. So even though this is not officially part of the notes for this lesson, I want to explain a little bit about the distance formula and do a quick practice question here. The distance formula is basically when you take two coordinates on a coordinate plane, subtract the x's, subtract the y's, square those results, add them together, and then do the square root. Basically what you're doing there is kind of a modification of the Pythagorean theorem. So this is typical of what you're going to see in a couple of the questions in the homework. They're going to say find the coordinates for 2 points on the line y equals 5 that are 6 units away from the point 3, 1. So they're going to give you a point, they're going to give you a line, and they're going to give you a distance. So I'm going to show you how to accomplish that using the distance formula. So what they're saying is here's our coordinate, pretend that it's accurate. And I did go ahead and fix my graph here so that it was accurate. So it is an accurate graph now. Find the coordinates for 2 points on the line y equals 5. So here's my line y equals 5 here. It's a horizontal line. And then I need 6 units away from this dot. So it says 2 points. And that's because if you go one way to get to the line, you could also go another way to get to the line. So it could go in either direction from that point and reach the line itself. So they're saying that it's 6 units away. Now keep in mind that I did not measure these. I'm just eyeballing it here. This is the approximate way that you'd figure it out, or the approximate way that it would look. And so they want to know where these two coordinates are located. Well, one thing we know is that the y value is going to be a 5 because they gave that to me here. And then I also know one of my x's and one of my y's right here because that's the coordinate that they want me to use. So I'm going to go ahead and fill those values in. So I'm going to have a big square root. I don't know my x, but I know one of them is a 3. And then I know 5 is one of my y's, and that's going to go with the 1 for the coordinate. So I just filled in 3 and 1, 3 for x, 1 for y, and then my other y has to be a 5. So now I'm just going to do a little bit of order of operations here to simplify, and I'm going to figure out what my values are for x. So when I do x minus 3 squared, that's going to give me, oh, and I know that the distance is going to be a 6 here because they gave me that value as well. So now let's solve that for x. So the first thing I got to do is release all of my stuff from being underneath this big radical. So I'm going to square both sides as my first step. That's going to release all of these items so that they're no longer under that radical bar. And let's calculate here. We know that 5 minus 1 is going to be 4, and 4 squared is 16. So we can get that accomplished right away. And 6 squared is 36. So now my goal is to try to simplify and solve for x. So I'm going to move the thing that's further away, which is the 16. I'm going to subtract that from both sides. And so if I subtract that, I'm going to get a 20. Still trying to solve for x. Now resist the urge here to do FOIL. We don't need to do FOIL here. That's going to make our job harder. Remember, we're trying to solve for x. We're trying to isolate the x. So to do that, we want to get rid of the 2, not by distributing it, but by making it go away. So we'd want to square root or raise to the 1/2 power on both sides. So when we do that, now the bar and the 2 are gone, leaving me just x minus 3, which is a good thing. Over here, I'm going to get square root of 20. That's going to end up being a decimal, and so I'm going to wait and get the x alone, and then I'll type it in on my calculator. So I'm going to add 3 to both sides. So now I'm going to have 3 plus square root of 20. Keep in mind that the square root of 20 is actually going to be plus and minus, because it could be one of 2 numbers there. And so now I'm going to type that in on my calculator. 3 plus square root of 20 and 3 minus square root of 20, and I'm going to get 2 results. When I do that, I get about negative 1.5 and 7.5. And so that represents where my coordinates would be. So actually, if I drew this a little more accurately, 1.5, negative 1.5 is going to be over here. And then my 7.5, 1, 2, 3, 4, 5, 6, 7.5 is going to be about right there. So then the purple lines is actually my more accurately drawn lines with a length of 6.